Okay, so first we need to get our calculator here, and I'm going to enter this function into the calculator. I've already done so, and but now I need to set up the wheel window x from -5 to 5 as required. 5, and I'm not too sure about the y minimum or y maximum, so I'm going to put some large value to cover all possibilities. Okay, so I'm going to sketch it now. Right, not too bad, my choice of y, but apparently it's not good enough, so let me increase. It's very important for me to get the graph right. I'm going to see all the important features. I got it. And I'm thinking probably we're going to use the graph a lot to solve the other parts, and so make sure this is on here. And now the coordinates of the turning point, as you can see, is this local minimum here, and so I can use the calculator to do the job for me directly. So, and the coordinates of the turning point is -3 and -243, right? And let's write this down. P is -3, -243. But first, I think I need to sketch this. Let me sketch. Simple sketch. Let's transfer the information from the graphics calculator. It's 5, -5. From here, look a bit like this. Okay. So this is your point P, and the curve passes through 0, the origin. I mean, so okay. So I have this now. Part 2, the coordinates and nature of points of inflection. I suppose I would just differentiate it to and find my point of inflections. I need the second derivative, so I need d squared y dt squared. This would be okay. If you think about it, all three terms have a common factor of 12, so I end with this thing here. And you probably realize that this quadratic can be factorized. It's 3t plus 5 and t minus 1. And so we have the critical values of 1, and from this factor, -5/3. I'm not going to find y by calculation, just use the calculator. I can trace this. I enter the value of 1, and so I have it at 113. So I have inflection point of 113, and the other one -5/3. I need to find the corresponding y. It's very simple, just trace again. So I enter -5/3. It's approximately -138.7, and -138.7, and we can actually determine the nature of these two inflection points by looking at the graph, because you see here is where when t is -5/3, it's non-horizontal, and it is an inflection point. So this point is non-horizontal inflection point. Okay, and the other one actually if you look at it, is somewhere here, 1, right? That's right, dy dx 0. So this is actually horizontal. If you draw a tangent line, it's horizontal to the x-axis, I mean parallel, and it's horizontal. And so this 113 is actually a horizontal inflection. So just by using technology, you can determine the nature of this. And so find the area between the graph and the t-axis from point P to t equals to 3. Now where is that? So point P is here, somewhere here, and corresponding t value is -3. So I can't and they want you to find the area from here until when t is 3, and I can't do it one swoop. I had to do it separately. So I'm going to integrate using technology. The lower bound going to be -3, but to 0 now. Right, so I only take the value itself, not the sign. So the error is 367.2. So the integral of -3 to 0 of the function is 367.2, and then I'm going to integrate from 0 to 3 y dx. I'm going to use the calculator again. So this we're going to lower bound will be 0, upper bound is going to be 3, and so the answer is 118.8. It's 118.8. So therefore the area is the sum of these two values. Area is just add them up, is going to be 4x6 unit square. And so we're done for part B. Let's move on. Now read about this. So the function can be used to represent a rate of energy respect to time, dE dt. But now we have a new interval from -3 to 5. And alright, so and this all this part about sunrise and so on. So at what value of t has the metal gain neither gain nor lost heat? Means that we are being asked when is this happening, when the rate of change of energy is 0. So there's only one such point. You look at the diagram. Okay, let me clear the screen first. There's only one such point, and that point is when y is 0, because now y is your is dE dt. Let me switch off this not to confuse you. Okay, as you can see, y now represents dE dt. So when this happens when t is equivalent to 0, right? And when it achieves minimum rate, well, clearly you can see from this minimum rate, when the rate of change is lowest possible, there's only one such thing, one such point, and that's when point P. So that means we're talking about when the second derivative is 0, and that is when at point P or P equals to -3. Okay, so that's that. And moving on. So a heating element is turned on and delivers heat to the metal at constant rate 80. So find the number of heat units. So because the rate is constant, and so the number of units of units is in fact 3 hours times 80 units and 240 units. Okay, it's actually pretty straightforward because the rate is constant. And so part E here, then calculate total heat gain or loss by the metal in the time from point P to T equals to 3 from natural effect and so on. So we're going to calculate the heat loss or heat gain, and so we're going to look at the diagram again. Think about it. Now from this is P roughly here, so from P to T, T equals to 0, we have a heat loss because the area we're going to calculate is actually negative, so it's going to be heat loss. And from T equals 0 to 3, it's going to heat gain because it's the area is positive, the integral itself. And also there is artificial element, and as you look at question D here, artificial element adding 240 units to the system. And so you might recall in part B just now we calculated the area and thing. So from P to T equals 0, the heat is lost equals to negative 367.2, and then T equals to 0 to T equals to 3, we have a heat gain because the area that you're going to, rather the integral, is going to be a positive value. And then finally from heating element, it provides 240 units. So that means the total heat will be equal to negative 367.2 plus 118.8 and plus 240 from the artificial heating element, and this value is negative 8.4 units. So that means the conclusion is we have negative. That means that we there is a heat loss of 8.4 unit from time equals to negative 3 to 3. So I hope you understand what does taken place, and hope you try the other questions, and all the best.